students, in this lecture I will explain how to draw the trellis diagram for a given convolutional encoder. The question is, below figure depicts a rate of constraint length 1 convolutional encoder. Sketch the trellis diagram and also find encoder output for the input bit stream 11101. In order to find trellis diagram, we need to prepare the state table for the given convolutional encoder. In the given convolutional encoder, the first flip-flap is MSG and the next is for M1. So here MSB is used to hold current message bit and M1 represent state of the encoder. Only one bit is reserved for the state of the encoder because the constraint length of the given encoder is 1. L is equal to 1. As one bit is reserved for the state, only 2 to the power of 1 is equal to 2 states are possible, state 0 and the state 1. If 2 bits are used for state representation, we can have 4 possible states. If 3 bits are used or constraint length is 3, we can have 8 possible states. If 4 bits are used, then we can have 16 possible states.
Let us understand how to prepare a state table for a given convolutional encoder. Initially, the given the encoder is at all 0 state, 0 state. Initially, it will be in 0 state. So, state of the encoder is represented as M1 and initial state. Initially, it is in all 0 state. And see, the state of the encoder depends on the incoming message bit. Whether the incoming bit is 0 or whether the incoming bit is 1. So, the change of state depends on the incoming message bit. So, see here for initial state 0, let us assume 0 state. If the incoming bit is 0, it is in the 0 state. If the incoming bit is 1, 0 state, initial state. Because 0 and 1, because it is a binary convolutional encoder, we have only 2 possibilities. The incoming bit may be 0 or may be 1. Again, initial state, we assume 1 1 for incoming bit to 0 and 1. So, state 0 is represented with letter A. Let us represent bit 1 represent state B. State 1 is represented with letter B. So, initial state may be AA, BB, something like this. If 2 bits are used for the state representation, in the case of constraint length 2, we can have 4 states, and we assume 0 represent A, 1 represent B, 10 represent C, and 11 represent D. But in our example, only 2 states are available, either state A or state B. First, we try to find encoded output of the encoded output of the convolutional encoder, given convolutional encoder. From this diagram, we can say x1 is equal to MSG. This is MSG, and this is M1, and x2 second output MSG, exclusive R of MSG plus M1. So this is the output to 2 and output to 1. So here we can find directly x1, x2. the output, final output will be, we represent with x1 x2 x1 x2 x1 x2 like that. So if you find, suppose if MSG is 0, we get x1 is equal to 0, x1 is equal to 0 we get, this is x1 x2. If x2 will be, M1 is 0 and MSG is 0, we will get 0 plus 0, this will be 0 0. So the output of the encoder will be 0 0. Similarly, we can find output of the encoder using these equations. Here this symbol represents XOR logic or modulo 2 addition. Let us calculate the next states of a given convolutional encoder. The state of the encoder changes only after applying the clock pulse. If you apply clock pulse, then only the state of the encoder or a shift register will get changed. Suppose the encoder may be at 0 state or 1 state, depending on the initially at 0 state or 1 state, depending on the incoming message bit. In step 1, suppose let us assume it is at 0, the state of the shift register or the state of the encoder is 0, and if this red bit, the bit color in red represents incoming bit, if the incoming bit is 0 and the state of the shift register is initially at 0, after applying the clock pulse, this 0 goes out, it will be discarded, this 0 comes to, sorry, this, okay, after right shift by 1 bit, this 0 will be discarded and this will come to M1, MSG will come to M1 after applying 1 clock pulse, right shift by 1 bit. So the state of the encoder changes from 0 to 0. So that is why 0 represents A. The state changes from current state, present state A to next state A. And in the second step, we assume initial state is 0 and we assume the incoming bit is 1. The incoming bit is 1. So these are the contents of the shift register. Then the state will change after applying the clock. So this 0 will be discarded and this 1 will come to M1 place. So M1 represents state of the encoder. So state of the, this one represents state B. So it changes from initial state 0 to state to B. State to B. If the incoming bit is 1 and initial state is 0. In step 3, we assume the state of the encoder is 1. It is at state B. It is at initial state B. And we assume the incoming bit is 0. After applying the clock pulse, this 1 gets discarded. This 0 comes to M1. So this is nothing but state A. So M1 represents state of the encoder. So if the incoming bit is 0, the state changes from state B to A. B to A. So this is the initial state and this is the final state or next state. In step 4, again we assume the encoder is at state B, that is it is at state 1, and we assume the incoming bit is 1 and we apply the clock pulse. This one's go to, it will be discarded and this one comes to here. So state changes from 1 to 1, that means B to B. State changes from B to B. So try to understand to prepare this state table, because this state table is very useful to draw state diagram, code trellis diagram, tree diagrams. These diagrams are graphical representation of convolutional codes, related graphical representations. So from these graphical representations we can find output of the convolutional encoder for any given input. So this will be the present state, and after applying the clock pulse we change it to these states. So initial state is like this, and next state will be, you blindly remember, next state will be always the first column. In case of L1 means constraint length 1. For constraint length 2, first two columns will be there. We will see that in next example. So the initial state is this one, and both will be same. State A, AB, AB. So this is AB, AB.
We have seen the procedure to obtain the state table. So now we try to draw the trellis diagram for the given convolutional encoder. So in the left hand side we use current state, on the right hand side we represent next state. Suppose we start from all 0 initial state. To draw this code trellis diagram we use conventions like, if the incoming bit is 0 we use solid line, if the incoming bit is 1 we use dotted line. So see, we are at initial state A is equal to 0, and if the incoming bit is 0 then state changes from A to A, present state to next state. So we use solid line to draw this diagram. So suppose if we are at initial state 0 and the incoming bit is 1, we use dotted line, state changes from A to B. So the current state A to next state B. So we use dotted line to represent this case. And if initial state is 1 and the incoming bit is 0, state changes from B to A. So from B to A, as the incoming bit is 0, we use solid line to represent this condition. And if the initial state is 1, present state or current state is 1 and the incoming bit is 1, state changes from B to B, B to B. So for incoming bit 1 we use dotted line, we represent like this. So finally from this state table we can draw code trellis in this manner. Also other way of drawing the trellis diagram. The same procedure we use, current state, next state, and we use the state table to draw this. But on the branches we use 0 by 0 0. In this fashion we use. Suppose 0 by 0 1 means input by output. This 0 represents incoming bit and the corresponding output is represented by this manner. So it avoids the use of a dash line notation. So we have understood how to draw the code trellis or a trellis diagram for the given convolutional encoder. Now we will try to find the output of the encoder for a given input bit stream. Suppose 11101. Initially we start from all 0 state. We start from A is equal to 0 state and check the incoming message bit. The first incoming message bit is 1. So see from node A, if the incoming bit is 1, state changes from, suppose see here, state incoming bit is 1, state 2 changes from A to B, output is 1 1. So now we are at node B. See from node B. So if the incoming bit is the second input bit, this is again 1. So state changes from C here. So if it is 1, state changes from B to B. So the output is 1 0. Similarly, we can find other output conditions to find the final output. So finally we get for the given input sequence, encode output will be 1 1 1 0 1 0 0 1 and 1 1. This way we find the output of the convolutional encoder from the trellis diagram. If you want PDF files of my video lectures, please visit www.engineerstutor.com. For PDF link, see description of the video. You can also write to me at rkgopal2020@gmail.com for any doubts and queries.